we really don't see from our perspective much change, and we haven't for, you know, a long, long time. I've seen a change once, and I'll tell you about it a bit later. It was actually kind of exciting. But anyway, so here we're getting close to sunset. Now, what do you think the first objects that you're going to see as it gets darker? What are the first objects that are going to start to appear? The moon, definitely. If the moon's up, it's bright, it's reflected sunlight, of course, so it's going to appear even before the sun goes down, pretty much. So what else?
Planets.
Planets, definitely. So planets do tend to be brighter, they're closer, they shine by reflected light, they tend to be brighter than stars from where we are. So the... Actually, you have. I bet you have. I'm going to show you. I bet you have. What you probably thought was a bright star, it might have been a planet. Because planets just look like bright stars, really, without binoculars or telescopes. And you can tell they're planets for various reasons. And when we get into the darker sky, I'll show you, actually. So anyway, here the sun's almost down. And I want to make sure I press the right buttons here. So here we go. So we get sunset, things get a bit darker. I don't want to go too fast because sometimes I've rotated like crazy. And so here we go. So here's the, gets darker. And I think you'll see some things start to come out.
Something on the right there. Or is that your cursor?
I'll make it go even a bit faster. There we go. Okay, there we go. Okay, so look what we have there. We see a few stars, like there's one right there. And if the great thing about this program is if I click on something, you get all sorts of information. Really? So I can click on that, and that's the star Arcturus. And you get tons of information about it. So you learn a lot of astronomy just by using this program, right? But anyway, I'm just going to move us over and looking right south, and this is why I'm saying you've probably seen planets because you've probably seen these, okay? This one right there is actually Jupiter. That's the planet Jupiter. It's fairly bright, and it looks like it's right near it. Of course, it's not near it at all. It's way, way, way further away than Jupiter. But we have Saturn. And it'll just look like a star, not as bright as Jupiter. And then we have the moon right there. So the great thing is I can zoom in on any of those. So let's...
They built two big buildings in front of mine now.
That's right. Now the thing is, you have to go to a place where there's no buildings or trees in the way, right? So that's why I usually use this field in France, because there's no big trees or buildings, but you can actually change the background in this, which is kind of cool. So I'm going to zoom in on the moon. So what I do is I click on the moon. You get all sorts of detail about the moon. And I'm going to center the moon, and I'm going to zoom in on it. So here we go. So that is actually what the moon will look like tonight. It's a little past what we call first quarter. And that first quarter, it looks like what they call a half moon, but it's really called first quarter. So it'll be pretty much down south. So it'll be right about sunset. It'll be kind of halfway between the eastern horizon and the western horizon, pretty much. So when the sun sets, it'll be about up there. So here we have the moon. And in a telescope or binoculars, who has binoculars here? Anybody? Anybody have a telescope? Okay, so if you have binoculars, try looking at the moon through binoculars. You'll actually see some detail on it. So here we have some darker areas and some lighter areas, and there's some craters that you can actually see. In fact, these darker areas, what they are lava plains. They're flat lava plains. And we call them seas or oceans on the moon, but of course, there's nothing to do with water. Right? You've probably heard of the Sea of Tranquility. Why is that famous? Yeah. Okay. So in Sea of Tranquility, that's where Apollo 11 landed. The very first time we landed on the moon. I can show you exactly where that was. Okay, so Sea of Tranquility is right here. This lava plain right there. And
Is it a crater?
it's a big flat lava plain. What's happened, actually, what we think, is that a lot of meteors, what's causing the craters on the moon are meteors coming down and smashing onto the moon and driving material up and out. And this happened a long, long time ago. What happened here, a lot of meteor bombardment, and it caused some lava that was in pockets, we think, underneath the moon's surface to well up and then cover the area and cool down. So we don't have a lot of, we have some craters in those areas, but not a lot. These seas or oceans are newer areas. You can actually tell by the crater count how new the area is. If it's an older area on the moon, a lot more craters. A new area on the moon, not so many craters. So this is the Sea of Tranquility. The Apollo 11 landed right about there, if you can see my cursor, right about here. They're given really neat names, like there's one called the Sea of Crisis, there's Ocean of Storms, there's Sea of Rains, things like that, like really neat names, actually. Okay, so I'm just going to zoom out on the moon now, so you can definitely see the moon. And as an astronomer, as a space enthusiast, shall we say, you know what? I'll tell you the truth. I never tire of looking at the moon. The moon is just beautiful. In a telescope, you can see a lot of detail, even in binoculars. Now, if you want to see some fainter objects, let's say fainter galaxies or nebulas or other faint objects like that, perhaps it's probably best not to have the moon in the sky, because the moon creates a lot of light also. And so if you want to see something in a really dark sky, you might want to wait till the moon is closer to the sun, so they either set or rise about the same time. But anyway, I always like seeing the moon. So here we have the planet Jupiter. You have a question, sorry? No. Okay, planet Jupiter, planet Saturn. Let's take a look at them. So I'm going to zoom in on Jupiter, and let's take a look at what it looks like. And you can actually see this. You can actually see some of this through binoculars. Mostly, though, you need a telescope. Jupiter is really my favorite object in a telescope. There we go. So that's the planet Jupiter right there. And it's a huge, it's a huge, what we call a gas giant. It's mainly made of gas, hydrogen, helium, some other gases like methane mixed in there. And you can see them as cloud bands. There's a lot of cloud bands showing you various gases that are in the atmosphere. And the clouds are streaked across like that because Jupiter rotates in about 10 hours. So it's a huge planet, yet it rotates fairly quickly. And in a telescope, what you'll actually notice is it looks like it's a little bit squashed, like the distance between the poles this way is a little less than the distance between right through the equator this way. And it's because it's mainly gas, this planet.
Isn't it solid rock in the middle?
Pardon?
Isn't the middle rock?
Well, what we think is, you know, this has been debated. Mercury, Venus, Earth, and Mars are the rocky planets. So they're the ones that are more like the Earth. You know, they have a rocky core, rocky surface, that sort of thing. Not much atmosphere, if any. And Jupiter, Saturn, Uranus, and Neptune are all gas giants. So they have mainly gases. It's a huge atmosphere. Now, what we think maybe towards the center is some of the atmosphere might actually be so compressed it becomes a solid. So in fact, we might even have something called metallic hydrogen in the middle of Jupiter. We may not have a real core. We're not sure. We're not sure about that.
It's just gas. What holds it together?
Yeah, gravity.
Oh, it's any matter any mass has gravity, and so even if it's a lot of gas, it's still pretty massive. So what we have here, we can actually see. Oh, I should probably not let it go away. There we go. What we actually see are, when you look at Jupiter through a telescope, we actually see what look like little stars near the planet. I'm going to zoom out a little bit so you can see maybe more of them. There we go. And these four, this isn't, I think this is just a star. Whoops. Sorry about that, that happens. Okay, in any case, these four, this one, this one, this one, and this one, they look like little stars almost beside the planet. They're actually four of its moons. Jupiter actually has about 70, I think the most recent count is about 79. Now we can't see those from Earth. A lot of those we see because we've sent probes and they've taken pictures around Jupiter and they actually see that they're moons because they orbit the planet. And in fact, these moons, a lot of them are captured asteroids, which are big chunks of rock that are floating around in space. Jupiter has a lot of gravity, and the asteroid belt, where a lot of asteroids are, is located between Mars and Jupiter. So Jupiter, no doubt, with its huge gravity, has captured some of these big chunks of rock, and some of them are very, very big, you know, kilometers in diameter. But these ones were actually discovered by Galileo with a small telescope, actually smaller telescope than many of us may have right now, you know. So you can see Jupiter like this in a telescope, and it's really, really neat. These are four of its moons named after nymphs in Greek mythology. Ganymede, Europa, Io, and Callisto are the names. And you may have heard of a few of these moons. At least, I think you may have heard of this one, Europa. It's a fairly famous, it's been in the news for a really good reason. Does anybody know the reason why Europa is kind of famous? Yes, yes. Actually, there are more moons now that we think have a subsurface ocean. When we look at Europa, I'm going to zoom in on it just so you can see. And you can't see much detail on it. It actually looks like ice. That's in a lot of ridges and cracks in the ice. You can't really see it on this picture, but in real pictures of Europa, you'll be able to see it. So we figure there's a subsurface ocean there. So wouldn't it be interesting to take a sample of what's in that ocean? So there is a probe, I believe. There is a probe going to go to Jupiter. I don't know when it's going to be launched, but hopefully we'll land on Europa and drill through the ice and get a sample of the ocean. We figure that it's probably salty water, which is really interesting because if it's salty water, that's like, you know, oceans on the Earth in a way. And you may think, well, isn't it too cold for any life to be there? But as you go down in this ocean, Jupiter pushes and pulls on the moons a little bit, creating what we call tidal friction. And what that does, it creates some heat. So as you go down in the ocean, we figure that it's not totally frozen. In fact, it might be actually, there's maybe some temperate areas. And so it'd be interesting to find out if anything is in this ocean. You know what? Even if it's, here's the thing, even if it's microbes, if we find microbes somewhere else, we found life elsewhere. And so actually, I graduated in microbiology. I took various astronomy courses, but I really graduated, my major was really microbiology. And so I'd be very excited if we could find microorganisms somewhere else that originated there and not through some contamination on the Earth.
Why do you think it's salty water?
Oh, okay. There was a moon of Saturn, and I'll show you this moon too when we zoom into Saturn, called Enceladus. And there was a spacecraft, I think it was Cassini, which was the one of the recent missions to Saturn, took a lot of great pictures. We actually saw some geysers coming off this moon, Enceladus. And in fact, I believe the spacecraft either flew through one of the geysers and was able to sample a little bit and found it was salty water. So we're figuring it probably the same thing on Europa. It's a guess. But that would be really interesting. So anyway, some secrets that might be discovered on Europa might be, could be some sort of life, but who knows? Jupiter is interesting on its own. It has its own magnetic field. It actually prevents comets from coming in and possibly getting too close to the Earth. It actually will sweep up some comets that are coming in other space, other asteroids, that sort of thing. So Jupiter does us a good service, actually, by kind of keeping these things from maybe coming too close to the Earth. So anyway, Jupiter's a really interesting planet. It's really great in a telescope. So let's just take a very quick look at Saturn. And you've probably seen Saturn and not know that you've seen it, because it just looks like Saturn actually just looks like a star. So does Jupiter with the naked eye. But even in the binoculars, you won't see the rings. You really need a telescope. But even a small telescope will show you the rings. And so I'm going to zoom in on Saturn, and let's take a look at it. And in a small telescope, this is actually what you will see. I'll zoom in even a little further. There we go. Now in a smaller telescope, I mean, you're going to be, the image is going to be smaller, so something like this maybe, but I'll just zoom in. You can also see some moons of Saturn. Saturn has, I believe, about 60-something moons. 60-something.
Wow.
It's another big planet. It's actually pretty massive, but the density is very low because it's a gas. So some people have said, if you could take Jupiter and put it in an ocean, like a huge, huge, huge ocean, put Jupiter in an ocean, it would float because its density is less than water. And so same with Saturn, it would be. But anyway, a very interesting, yes, I do see Enceladus, there it is. That's that moon I was talking about that had the geysers. This one right there. And another really interesting moon of Saturn's is Titan. This one right there. And Titan is a really interesting moon. It has an atmosphere. It's one of the only moons that has an atmosphere. And the atmosphere is methane, a lot of methane in the atmosphere. We're actually going to send a probe. We've already sent a probe to Titan, but we're actually going to send another one, I believe, meaning NASA. So Titan is a very interesting, for really some of the same reasons. Who knows what we will find there? Because it doesn't have oxygen that we know of. But of course, early on in the Earth didn't have oxygen either. And we have bacteria that are here on the Earth that are anaerobic bacteria, which actually don't require oxygen. They will live when there's no oxygen there. So anyway, it'll be interesting to see what Titan has in store when we send probes there. And by the way, what do you think? What do you think the rings are made of? Some people have asked about that. You know what? Actually, they're almost like, you can almost think of them as dirty snowballs. They're like small chunks of rock with ice, and a lot of them, and fairly small close together. We do have a few gaps in the rings. There's one right there and there's a smaller one right there. So anyway, we do actually see, you can actually see that through a telescope. So Saturn's a pretty amazing.
Because it's spinning in the gravity, it goes around it like that.
Yes, each particle in the ring, it's orbiting the planet. We're thinking that possibly the rings might have been made of a few moons that have a long time ago smashed together and create a lot of little bits, and then eventually with the orbit around the planet, eventually went out in kind of a plane. So we're thinking that was true. Saturn's not the only planet in our solar system with rings. Which other ones? Anybody know?
That has what?
Rings.
Uranus?
Uranus, yes. Definitely. Uranus has rings, and there's a lot of jokes were made on that one when that was first discovered. But anyway, Uranus has rings. Jupiter has rings. Neptune has rings.
Really?
All the gas giants, they have rings. Now, they can't be seen from Earth. Jupiter's are very faint. Saturn's can be seen from Earth. But again, Neptune's can't be seen from Earth, and Uranus's can't be seen from Earth either. So anyway, they were seen by probes that we've sent by these planets to take pictures of the moons and stuff. And it just happened that they actually saw these very, very fine rings being on the right angle for the picture.
Would the rings of different planets be made of the same thing? The rock, the ice?
Probably, but not their composition. I'm not sure. Tell you the truth, their composition may be a bit different, but I would believe that they would be, dust particles, larger, smaller chunks of rock with some ice and stuff like that. But maybe Saturn's rings are very reflective, so maybe more ice. Okay, so we're just going to zoom out. And let's take a look at what you really need to do to find your way around the sky is to know some constellations. And of course, from Toronto, we really can't see too much. I can remember when I was a teenager and I went outside, you could actually see most constellations, especially if you got up at 3 o'clock in the morning, like I was crazy enough to do at that time. When the sky was relatively dark, even from Toronto, we could trace out constellations. Right now, you're lucky if you even see some brighter planets and some of the brighter stars, that's it. It's just too much light. And we call that, of course, light pollution. You've probably heard of light pollution. And this has happened even in smaller urban centers. I can remember up at our cottage, which is up near Parry Sound, it used to be beautifully dark and the stars just hung out like diamonds when I was a young person. But Parry Sound has grown, and now there's really a glow in the sky. You can still see the Milky Way, you can still see a lot of stars, but there's a glow in the sky, unfortunately. So if you really want to go to a dark sky, we have dark sky preserves. Now, we almost need them. There is one up north of Gravenhurst called Torrance Barrens is one. There's another one in Jasper. There's a bunch. You could look them up online, and they would be places to go if you want a better dark sky, especially if you want to take pictures of the stars. Oh, the desert is great. Yes, I've been to Southern California and Arizona and New Mexico. And the desert at night, but there, Southern California, it's great. At night, you get really nice clear skies because the humidity's low. And they have some observatories like Kitt Peaks down there. Mount Palomar is just outside San Diego. And that's that huge 200-inch mirror telescope. So the desert is a great place. So anyway, while we're looking at this, the night sky, I would like you to see if you could see anything strange as we're looking. Just put up your hand or say something if you do see something strange. I'm going to see if I can find them too. Anyway, so just like we have in atlases, we have where countries are and cities are and all that. In the sky, we have constellations. So I could say, for example, that Jupiter right now is in the constellation of Sagittarius. But you have to know where Sagittarius is. That would mean nothing really unless you knew where it was. So I'll show you a few constellations that are pretty recognizable. Here's one right here. And this one, I'm just going to zoom in so you can see more of the stars in it. Right here is part of the constellation. It's a part of the constellation, kind of like the Big Dipper is part of another constellation. The Big Dipper is actually part of the Great Bear. This is part of the constellation, and it's part of the constellation Sagittarius. It actually is Sagittarius. But you recognize Sagittarius by this little group of stars. What does it remind you of? Does it remind you of anything, just that shape? Yeah, that's actually a good guess. Think of maybe, I don't know, something you might have on your breakfast table. So check this out.
Teapot?
Yes, a teapot. Yeah, we call this the teapot. And it's not a constellation. It's part of Sagittarius, but it's a recognizable part. We call it teapot. So there's the top, here's the spout, there's the handle, so there's the teapot. And I can put some lines in there showing you, so the teapot's right there, with some lines coming off to some other stars in Sagittarius. That's it. The trouble is, in Toronto, you're not going to see this. You know, you just really have to go out of the city when it's to a much darker sky.
So constellation means a group of stars.
A group of stars that seem to look like something, seem to look like a pattern. And in ancient times, people in the Middle East, let's say, and people all over the world really, saw what they thought were patterns in the stars. And it had to do with maybe their culture, it had to do with their mythology, what actually they saw as these patterns. So the native peoples of North America would have had slightly different names for some of the constellations, obviously. The Europeans, we usually use the Latin names for the constellations and all that. So the ones that's seen from Europe. The Middle East, some of the stars actually have proper names, at least the brighter ones, and they have Arabic names, and they still do. So anyway, I want to show you a group of stars that I'd like you to try to find. I'll just take this out again. So you probably won't see Sagittarius, okay? It's just maybe too faint and too down south. But if you look up here, so you find Jupiter, Saturn, that should be fairly easy. Find the moon, look up from that, just straight up, and you'll see a group of stars. Actually, there are 3 different constellations here. Okay, so here's a star right there. And even from Toronto, you should still see these stars. Okay, so there's this one called Deneb, this one called Vega. You may remember there was a car named Vega way back when, right? I had a Pacer, by the way.
Or remember the big sandwich?
Yeah, the big space, they called it the space bubble, but anyway. So Altair. So these 3 stars, you'll see a big triangle. So we call it the summer triangle because it's really all summer, basically, you can see this. You can still see it actually, because this is tonight's sky, and you just look up from south and you should see it right up about there. Okay, so it's actually made of 3 different constellations. I'll put the labels in. Okay, so here we have, actually I'll take that out just for a second. So one constellation is here, it looks like a cross. So here it is right there and goes out to here. So you could call it the Northern Cross. It's actually called Cygnus, the swan, because this is the head of the cross, Deneb, but it's the tail of the swan. Its long neck actually goes this way. So it's a swan with a long neck. Here we have the constellation of Lyra, which is a Greek, an ancient instrument called a lyre. Yep. And you can recognize it. I'll just zoom in a little bit. By a fairly easy way to recognize it is a triangle on top of a parallelogram. So I kind of doubt that you'll see. Okay, so I'll try to zoom in a little further. Here we go.
Are you allowed to draw the lines between so you can use your
Yeah.
Yeah, that's easier.
Is there a line you can draw?
Okay, so there's the parallelogram. And the triangle should also be including this star. So there is the triangle right there. I always include the star right there too. Okay, so that constellation is the Lyre, called Lyra. And down here, this constellation with Altair in it is the Eagle. Okay, so I'll just put, and that's in the constellation, the Eagle called Aquila. We use the Latin names for constellations. So you should be able to see the summer triangle fairly easily tonight. So you should go out and try to see it, unless it gets too cloudy, of course.
This
So
is what it will be like tonight.
this is what it would be like tonight. Now, I can also show you, there's a lot of constellations. You actually have the option of putting the artwork in.
Oh.
So it's kind of cool, right? So here's this is the swan, right? There's the eagle, here's the lyre. But you can see a lot of other constellations right there, many, and some you might have not have heard of. I mean, some you probably heard of, but some you might not have heard of before.
Is that Aries down there, the man?
Sorry?
Apollo or the guy?
Okay, so here we have Sagittarius. You've heard of some of these, I'm sure. Here's Sagittarius. There's Capricorn the goat. Here's Aquarius the water carrier.
Zodiac, yeah.
Here's Pisces the fish, right? Here's Aries the ram, right there. So you've probably heard of those. Why have you heard of those? Why are those ones famous? Yeah, they're the constellations of the zodiac. You can, and they also have to do with the horoscopes in your newspaper, right?
Right.
So,
Well, the theory is they're in a certain place in the sky, and if you were born there under that sign, like, right, there's some theory.
that's
that
right.
They are.
So why do they call, for example, Sagittarius, the archer, it's actually a centaur.
Right.
As you can see, he's not a regular guy. He has a horse part of the body too. So he's a centaur, and he's actually shooting an arrow at the scorpion. The scorpion's right there.
Right.
So anyway, we have Sagittarius right there. Why do we say Sagittarius is the birth sign for December people?
Because it's somewhere in the sky in December.
Okay, so the best time to see Sagittarius, to tell you the truth, isn't in December. It's interesting. It's almost the opposite. What happens is, as we go around the sun appears to take a path through the stars. So like as we orbit the sun, as the Earth orbits the sun, so let's say, you won't be able to see me do this, unfortunately, on Zoom. But anyway, so let's say that's the sun, here's the Earth. So if we're here, we'll see the sun against those stars. If we're here and move there, we'll see the sun against those stars. So it'll look to us that the sun's moved. And it continuously does that. And what does it do? It moves through 12 constellations, one for each month. And so a long time ago, thousands of years ago, the sun was in Sagittarius in December. Okay? So Scorpio is my constellation. The sun was in Scorpio in November. And in Capricorn in January, Aquarius in February, and so on. So it's where the sun looked like it was located.
Is that related to the Romans adding 2 months to the year or not?
That's, you know what?
Because November used to be the 9th month and September was the 7th month. So.
That's right. I'm not sure when they exactly named these, whether it was before or after that. I'm not sure.
Because we had a different calendar, haven't we?
Yeah, the zodiac constellations actually are where the sun, it's the sun's apparent path.
Right.
Okay, now there's a little monkey wrench I have to put into the works now. The Earth has wobbled a little bit on its axis, and it keeps wobbling a little bit as it goes around, and it takes a long time for one wobble. So right now, thousands of years ago, Sagittarius, it looked like the sun was in Sagittarius. But right now, it's shifted over one constellation where the sun actually is.
Well, I think that's why the climate's changing as well.
Would that affect climate change?
No. But what it would affect, though, is that our North Star, which is Polaris, we have right near our North Celestial Pole. Up, if you're at the North Pole, you can look straight up and you see Polaris, the star, right? It didn't used to be our North Star. Vega used to be our North Star a long time ago.
Wow.
It just, the Earth's wobbled. And it's going to do that cycle again. And I forget, I'll have to look up how long it takes for one wobble to do. But anyway, we're lucky right now that we actually have a way to find north. So I'm going to show you that actually in a second. So I'm just going to take out the constellation art and the labels and the lines.
Now, where is Vega?
Okay, Vega's right here.
And then where's Polaris?
Okay, Polaris is way up north. So I'm going to go over now. I'm going to go over to north. And here we go.
And that doesn't affect weather, right? Okay.
It's you know what, the wobble is, it's almost like a top. When the top slow down a little bit, starts going like this a little bit, but it takes a long period of time, like thousands and thousands of years, like for that cycle. I'd have to look up how long it actually is one cycle. But right now, it would be a good idea to know how to find north. So in this program, of course, there's north, right? So that's kind of cheating. But we don't have that in the sky. If you're out lost in the woods, let's say, and you don't have GPS, it would be a good idea to kind of know your directions. So at night, there is a way to find north. So what do you think you'd do to find north? Where exactly north is?
Well, look up in the sky and see
The Big Dipper.
whether, if there's any clear, I mean, it's not clear, you can't tell.
Okay, so actually Dr. JJ is correct that it would be a good idea to at least know where to be able to find the Big Dipper. Here it is right here. So I'm just going to zoom in a little bit right there. There's the Big Dipper. But the Big Dipper is actually part of a constellation, kind of like the teapot was for Sagittarius. The Big Dipper is actually part of the Great Bear.
Right. Ursa Major.
And it's Ursa Major, and it's actually the hindquarters of the bear and its tail.
Wow.
That's what the Big Dipper is. But actually,
The Bronchos.
Yeah, the bear, let's take, I'll just take the picture out for a sec. The bear, actually, its head is here's its feet down here. Its head would be out about here somewhere. So that's just the hindquarters on its tail. But there's the Big Dipper, so it's fairly easy to find. And it's going to be generally up north. The thing is, it's not exactly up north, because everything in the sky does move, except Polaris. Polaris moves maybe 1 degree, but that's about it. Everything else in the sky moves around Polaris, and I'll show you that happening, actually. So right now, we're not too far away from north. If you find the Big Dipper and you start walking that way, you're basically walking north. But it would be a good idea if you found something that's always north, and that would be, where's Polaris? So there's a really quick and easy way to find Polaris. So does anybody know what that is? Michael?
Look at the bowl of the dipper,
Yeah,
you just follow a straight line up. And it goes from there.
exactly. So these 2 stars in the Big Dipper, I'll just put the lines in again. These 2 stars here in the Big Dipper, those ones, we call them the pointers, just because they point to the North Star. So you go from this bottom one, the names are actually Merak and Dubhe. So anyway, going from this one through this one, you keep going about 7 lengths, and you come up to the nearest bright star would be this one, that's Polaris. Okay? So here's the thing, Polaris is not a bright star. A lot of people think it is. It's not. I actually challenge you to try to find Polaris in the city. It's not very bright. So why is it so important? Why is it so famous? It's not because of its brightness. It's not very bright at all. So, sorry?
Is that what navigators used to use?
Ah, okay. So we're gonna, very good question. We're gonna get into that right now. So anyway, so here's Polaris. I'm gonna center on Polaris. Now what I'm gonna do is I'm going to take out a few things so it won't confuse us. I'm gonna take out the atmosphere.
Right. Would you call it the pivot point?
In a way.
Yeah.
And I'm going to take out the ground.
Great.
So we don't have, we're not going to have day, night, day, night, day, night, flash, flash, flash when I do this, okay?
Right.
So here we go. I'm going to make the time go by. The Earth is going to start turning.
And that's the Milky Way over there.
Yes.
Right side, okay.
Okay, so we're just, I can talk a bit about the Milky Way too in a bit. So, okay, I've centered on Polaris. Now here goes the sky, watch. This is why Polaris is so important. It doesn't move. Everything else rotates around it. And the reason for that is if you were standing on the North Pole and our polar axis, which goes from the North to the South Pole through the Earth, right? If you're standing on the North Pole, you look straight up, you're going to see Polaris. It's right kind of where the polar axis points to. Actually, it's about 1 degree away. If you took a really close look at it, Polaris does a wee little circle, you know, but not enough to worry about. So
You call it Polaris, like, because that's polar, north.
that's right.
Polar, right?
Now, in the southern sky, they're not as lucky. They don't have really much around the southern celestial pole at all.
Or the Southern Cross, I guess.
Yeah, but they do have the Southern Cross. They have some amazing constellations. I've never been down there. They have amazing constellations that I've never seen. But trouble is the Southern Cross isn't really near the South Celestial Pole either.
No.
Anyway, so
Lost in the woods. You want to go south. You don't want to go north.
yeah, so at least if you can find Polaris by looking at the Big Dipper, you'll know where north is.
Right.
And if you know where north is, let's say north is that way, then you know, wait a sec, north is this way. Okay, so then you know automatically south is this way. right? And you know west is that way, east is this way. That would definitely help. Okay, so I'm just going to stop this for a sec.
Get off the road.
Here we go.
Love it. Would you recommend the Riverdale Park as a good place in Toronto because of the big bowl or not?
No place in Toronto is that great.
Okay.
Tell you the truth. I try to get away from apartment buildings and
Right.
parking lots and stuff. There is a place where sometimes people gather to do some, take telescopes and stuff, and it's up on Bayview, just north of Bayview and Shepherd.
Okay.
There's a park,
Right.
and you know there's trees around it and stuff like that.
Earl Bales?
Earl Bales, I think, is that what it's called? In any case, okay, so let's get back. I'm just going to put a few other things
Oh,
in.
Temptation Trail. And there's juice over there too. Look at daytime again. Look at daytime.
Yes, I'm just going to put everything back the way it was.
Okay.
Okay, where are we? There's the ground.
Right. So is that how they do that in a movie for special effects to make it look as if the stars are really bright? Or they go in the country?
They would, well, you mean for movies?
Yeah.
I suppose. They would obviously use computers and stuff.
Right.
But anyway, let's just see what time this is getting to be.
Right.
We're still in France, right? So they're
Yeah.
5 hours ahead of us.
No, actually, that was just let's check where we are. No, we're actually in Toronto.
Oh, okay.
This picture is just of a field in France, just for graphics.
Yeah.
That's all it is.
The Toronto sky.
Okay, so I'm just going to go back here. And what do we have here? 23:14. That's fine. So it's like 11 o'clock or so on the 23rd. Oh, wait a sec. 14.
I was watching an over.
Oh, no, you know what I did?
The stars are like billions of miles, like that star we see, the light. It looks close, right? But it's a light from billions of years ago. That I don't understand that. It's not actually a planet, the star, or
But
even
that
if it's
star had
gas.
died out because we're just getting alive.
That's right. Okay, so let's talk about that because that is actually quite important too. Stars are much further away than planets are. So we have a way of measuring how far stars are away. We give a kind of a yardstick for that called a light year. So you might have actually heard of what a light year is. So what have you heard about a light year?
The speed of light, I guess.
Yeah, it's the distance. It's actually a distance. A light year is not a time, it's a distance, and it's the distance light travels in a year.
So 186,000 miles per second.
Yes, about 300,000 kilometers per second or something, like 186,000 miles per second. It's,
The 3,000 miles is from here to England.
yeah, so like when you think of 300,000, it's really hard to get an idea of how fast that really is. But I can give you an idea, perhaps. And so let's look at the moon. We already did, but okay, so how long, you may remember 50 years ago, 51 years ago now, the Apollo astronauts first landed on the moon, right? And how long did it take the astronauts to get from the Earth to the moon? Do you remember? It was about 3 days. Yeah, for the transit from the Earth's orbit to the moon's orbit. It was about 3 days travel, okay? So that was nowhere near light speed. We don't have the technology even now to go anywhere near what light speed is. So how long do you think it would take you to get to the moon going light speed? Any guesses?
2 seconds.
Minutes?
2 seconds?
Actually, Dr. JJ's pretty close, a little over a second.
Oh my God.
That's how fast it is. So we could go like, okay, we're going to go to the moon. Here we go.
Yeah.
10, okay, 5, 4, 3, 2, 1. Blast off. We're there.
So,
That's basically it.
so when we get those teleporter beams going, we'll be able to live there.
Oopsie.
Yeah, okay.
DTC.
Would that be good? Okay, okay.
Yeah, it's the
I'm gonna go visit my aunt. Okay, there I'm good.
So let's take a look. Oh, I just saw something that was kind of weird, but I'll show you. Let's take a look at the stars here in the summer triangle. Let's take a look at Deneb. So I'm going to click on Deneb, and the moon is about 1 light second away. Okay, so that's about what it is. We call it 1 light second away. It takes light about 1 second to travel to the moon. How long would it take you? Well, how long would it take light to get to Deneb or from Deneb? If you go down here, distance. There's a bit of a plus or minus here, but it's about 1,411.9 years traveling at light speed. So Deneb, it takes light about 1,411.9, almost 1,412 years to get from there to here. Okay? Now this is really, this brings us up to this business about which you've probably heard about. Okay? So if you took a look at Deneb through a telescope tonight, so if you went out and took a look at Deneb, what are you actually seeing?
yeah.
The light that left Deneb that long ago is only getting here now and going into your telescope. So you're actually looking at Deneb as it was 1,412 years ago. So the further something is away, the more back in time, the older you're looking at it, the more back in time you're looking at it.
Boggles the mind.
So let's look at Vega. Okay, let's look at Vega. Vega is relatively close, 25 light years. 25. So it takes light 25 years to get from Vega to here. So if you looked at Vega tonight, we're looking at it as it was 25 years ago. And let's look at Altair. Altair, 16.7 light years. So these stars are a lot of different distances. And it's really interesting. What I like to do when I look through a telescope, I take a look at something and go, what happened in history, you know, when this light actually left that star? So I think everybody here could think of what happened in history 25 years ago. And definitely 16 years ago. But I think everybody here would be hard pressed to think of what happened exactly in history like 1,500 years ago.
Right.
But you could probably look it up.
Yeah.
So
Okay.
I think some of the stars eventually die out. Right?
Oh, yes. Okay. So stars actually go through an evolutionary process. Our sun is about, right now, about 4.5 billion years old. Okay, so it was formed out of a big gas cloud called a nebula. I'll show you a few nebulas here too. Big gas cloud called a nebula, and it started shining, and it has been going on pretty much the same over its period of time. It's about 4.5 billion years old right now. We think that the sun still has another about 4.5 billion years to go before anything major happens. So we're okay. We're okay for about 4.5 billion. We're okay for about 4.5 billion years.
I'm all right, Jack.
Yeah, we're okay for about 4.5 billion years. However, at that time, the sun is going to be using up its hydrogen supply. What the sun does, it takes hydrogen, smashes it together in a fusion reaction, making helium and energy and light. And the sun is going to be using up its hydrogen supply. So what happens then? Well, it's going to have to start fusing other things. So it'll start fusing helium. But to do that, it creates, the star has to change in size, and the star has to change to do that, to have those reactions going. So it's going to expand, we think, and get hot, and it's going to expand, and it's going to look a little more reddish, but it's going to be, the edges of the star will be a lot closer to us. When this happens, it's called a red giant. So the sun will turn into what's called a red giant, and the Earth will be pretty much uninhabitable, unfortunately, at that time.
Because it will be
Way too hot. There are much larger stars. The sun is actually a type of star we call a yellow dwarf. It's not like a white dwarf. It's called a yellow dwarf, a fairly small, regular star, not big. And what it'll do is turn into a red giant, and then after a while, cool off. It might blow off a little bit of its outer layers, cool off, become a white dwarf, and then stay that way for a while.
Another star will be a sun.
Yeah, but it's a little more complicated, the stellar evolution thing. I mean, I could get it, show you some graphs and all that stuff that they've done, but basically, stars like the sun are going to go from what it is now through the red giant to become a red giant, swell up, do that, and then eventually cool off to become a white, at least get really small and hot and become a white dwarf, and then eventually.
What's the white dwarf? You said it's a yellow dwarf right now?
The sun's called a yellow dwarf, but a white dwarf is kind of a special object. It's an old star, kind of at the end of its life. Now, large stars, I'll show you one right now. Whoops. Actually, large stars, I'll show you it when we get to it, but large stars, there are much larger stars than the sun. If they're really large, there could be a huge explosion called a supernova.
But they're so far away.
Yes, there is one though that we feel that it's fairly soon. We don't know when it's going to happen. It could happen anytime. This one starts in Orion called Betelgeuse. And it might go, Betelgeuse. It might go supernova. We don't know when though.
But when you say it's going to happen soon.
Anytime, we don't know.
But I guess, is it happening, I mean, it will be happening X number of light years?
Well, right now, Betelgeuse is a red supergiant. And
seeing it as it exists.
the explosion.
X years ago because of this.
That's right. So it could have already happened. And we wouldn't know until the light gets here. So I'll show you Betelgeuse in a second. But one thing that has come up, now what we have here, just to show you really quick, Mars is in the east. So you could
see Mars. We went up to the Dunlap and saw it. When
That's right. You can actually find Mars. It's in the east. Right here, it's about 8 o'clock, right? So Mars would be in the east, and it just gets higher and higher as the evening progresses. Mars is pretty amazing. It actually was very close to us recently.
Yeah,
And October 13th was the date of opposition, which means it's lined up on the same side of the Earth. And so we are about the same, we are as close as it's going to get in this orbit cycle. So it's a really good time to see Mars through a telescope. And so we did go up to the observatory and we did a virtual thing up there to see Mars. Now Mars, I just want to zoom in on it just to show you. It's a small planet, about half the size of the Earth. And Mars will look like that. Has two moons, Phobos and Deimos. Actually, Mars is the Roman name for the god of war, right? And Phobos and Deimos actually are from the Greek. They mean fear and death. So no wonder if it's the god of war. Of course, the god of war in Greece is Ares. Yeah. So we name our planets usually after the Roman names. Anyway, so you can actually see detail. You can actually see polar caps, like there's a remnant of one right there. Darker areas, lighter areas. Mars is a cold, dry desert right now. We don't know about life or if it had existed in the past. One interesting thing about it though, we know Mars had water in the past, a long time ago, by analyzing some of the rocks and looking at some features. We actually see some dried riverbeds on Mars. It couldn't be anything else. So Mars is of great interest to us to go there and see if there could have been something happening in the past with respect to life. We don't know.
How long does it take to get there?
To get to Mars, 6 months or something like that. And we have to time when we go for a Mars mission because planets have to be in the right places to be able to get there efficiently. Mars is, if it's way too far away in its orbit, it can be so small that we really can't see too much on it through a telescope. So we usually have to wait for opposition times to actually see it. So anyway, Mars is a really amazing place also. So you'll see Mars coming up in the east, and it'll be with us really all night. A few of these things that you might wonder about, like what are these? At different times of the year, we have what we call meteor showers. And it's when a lot of little chunks of rock, sometimes a grain of sand size, even pebble size, come into our atmosphere and burn up. And they usually happen at the same time each year. So for example, there's a really great one in the summer called the Perseids. You might have heard of those. They happen in August, around August 11th, 12th, and unfailingly, the Earth is in the right position for these little particles to come in around August 11th, 12th each year. And we have various meteor showers for different times of the year, and they're caused by comets. A comet actually has passed by, gone around the sun, and they're like huge chunks of rock with a lot of ice and break off pieces as they go around the sun, create a big tail, right? And they leave these particles in orbit, and the particles are still orbiting. So when the Earth's orbit intersects where the particles are, you'll get these meteor showers. And so it's usually one meteor shower per comet that we have. So these are where various meteor showers would be coming in, maybe around now. We don't see those things in the sky. Those are just radiant points. Pardon? Not usually in meteor showers. They're so small that they burn up. But at any night, a meteor could come in, and it could be larger, not part of a shower, and it could land if it were big enough initially.
They could be, people think they're UFOs. It could be.
Right.
Yeah.
Like that, right?
Yeah, UFOs, I keep an open mind.
Yeah, no,
Tell you the truth.
Saw something like that.
Yes, I mean, seriously, a long time ago, I saw an article saying, and the article in the paper saying, light in the sky was actually Venus. And so people saw Venus and how bright it can get and thought, what is that? And phoned the newspaper and thought, you know, it was a UFO or something. Right? Anyway, so I like the fall constellations. The fall constellations are so amazing. So all we have to do is just wait for the Earth to turn a little bit more. So we just have to get up later at night to see them even right now. Even some of the winter constellations, if you want to get up before sunrise, you'll see the winter constellations even right now. Just have to wait for the Earth to turn that much. So what do we have here? This is an interesting little thing. I'll just make the time go further. Okay, and up we go. And here are some of the interesting fall constellations, some fall things, winter things coming up. This little object right there, I'm going to zoom in on it. And it's actually a star cluster called the Pleiades. And it's an amazing, if you take binoculars, and it'll be in the east, coming up in the east. If you take binoculars and zoom in, with binoculars even, it's a large cluster. So you'll see something like this, which is really neat.
Wow, that is neat.
Now, all these stars in the cluster were actually formed from the gas cloud, a gas and dust cloud called a nebula. So that's why you see still some of the gas and dust cloud around where these stars were born from. And usually photographs, there's some that are easily visible, but usually photographs, you can see nebulas through photographs better. Anyway, these stars, if I clicked on some of these stars, what do you think their distances would be? We talked about light years, right? So I don't want you to answer necessarily how far exactly, but let's say if I clicked on, let's say this one Electra and this one Merope and this one Alcyone, what would I notice about their distances? They might be a little different, but they're not, they actually are fairly close together because they are close together in space, right? So if I click on this one, Merope.
So what counts as close together? What are we talking distance-wise?
Between them?
Yeah.
Geez, let's see. I'd have to, you know what, I'd have to look that up to tell you the truth for the Pleiades. It's a large cluster.
Okay.
But it would be, I'd guess a few light years, but I'd have to look it up.
Just thinking of the time too, Alex, can we maybe shift slightly to Q&A?
Yes, definitely. Okay, so just to show you a few other things. So Merope is about 380, Alcyone, 403, it's not too far away from 380, right? Electra,
You're talking light years?
yes, 404. So they are all kind of part of the same cluster. Okay, one more thing because of the, I'm looking at the time. One more thing I want to show you is, how about something really far away?
What's the farthest away?
Oh, well, we think the universe is about 13.8 billion light years across.
Wow.
And that's as far as we can see.
When you say across, is that from us to the extreme?
From us to where we can, from us to the furthest we can see.
Do you believe, I mean, it goes on forever.
Well, that's a good question.
Like, there has to be another galaxy out there.
No, it's a good question. If the universe is infinite,
Yeah.
or not, or
It's
what?
not infinite, what's behind that, like, it could be.
Well, I know.
So that, you can go on, like, what's behind it, like,
That's right. There are various theories, and just because of the time, I can't really.
well, we'd have to do another.
But it's yes, definitely. But it's a great question.
Billions and billions.
Okay, I just want to show you something here, and something fairly far. So I'm going to put some lines and labels in. Okay, here is something called the Great Square in the constellation of Pegasus. Pegasus is a winged horse. And I'll put the artwork in. He's kind of flying upside down. There he is. Okay. Now, coming out from one of the corners of Pegasus, we have the constellation of Andromeda. And you've probably heard of Andromeda. There's a really good reason why you've probably heard of it. That and we have to do star hopping to find this, this object I'm going to show you. Star hopping just means you go from one star to another star to another star. And if you know it's near another star, then you found it. So I look for Pegasus, and then I go for this corner, and I go 1, 2 stars, and I go up 1, 2 stars. There's something really interesting there. Does everybody see that? It looks like a smudge. So I'm going to just zoom in on it. Maybe you might not see it. There we go. Okay. So what's that smudge really? It's the nearest galaxy to us. All of the stars that you see in the background here and all of the stars I've shown you are in our galaxy, the Milky Way, which is a big pinwheel. It actually looks very much like what Andromeda looks like. This is the Andromeda galaxy. And it has a few satellite galaxies of its own. We have a few satellite galaxies too, called the Magellanic Clouds, but we can only see them from the southern hemisphere.
The galaxy means it's a group.
Stars, dust, and gas in a big pinwheel, huge.
Oh, really?
So from the Milky Way, from one end to the other end would be about 100,000 light years across. We used to think Andromeda was a bit bigger, but now we're thinking that maybe it and the Milky Way are more similar in size. But anyway, how far away is the Andromeda galaxy when you look at the distance? Here we go. About 2.5 million light years away. So if you looked at the Andromeda galaxy tonight through a telescope, you'd see it as it was 2.5 million years ago. And that's the closest one. So that's just like incredible. It's like mind-boggling, right? And what's between galaxies? Not much. Most stars are in galaxies. So you just have space between galaxies. And we now know space is expanding all over the place.
What causes it to expand? I mean, if there's nothing there, what's making it expand?
It's actually accelerating in its expansion. And we figure it's something called dark energy. And that's something, to tell you the truth, that I don't think anybody knows exactly what it is. People don't even know what dark matter really is. We can't see it, but we figure it has, it's one of the reasons why the universe something's pulling on all the objects, making them expand further and further and further, faster and faster. So physicists have suggested that there's something called dark matter, which actually is most matter. The matter that we see is a fraction of all the matter that's in the universe. Dark matter is more, much more. And dark energy is this force that is repelling things outwards. And I don't tell you the truth. I don't know. I don't understand it that much. I don't think too many people really do understand it that much. But all these things are totally mind-boggling.
Does that mean, like, planets planets are getting farther away from each other, stars are getting farther away from each other.
Well, you won't notice it right around here, but it does mean that whole galaxies would be getting further away from each other, or a lot of them are.
Yeah.
But actually, there are some variations. The Andromeda galaxy, to tell you the truth, is actually coming towards us. And it's going to intersect with us in about the same time that our sun becomes a red giant, you know. And what's going to happen? You might think, oh my God, that's awful. You know, so many things happening at once. But to tell you the truth, when one galaxy hits another one, you're hardly going to get any star collisions. The stars are still fairly far apart. So you'll have to take a look online and take a look at a computer simulation of two galaxies merging. And so they'll kind of pass through each other, and then they'll come back around and do it again, and come back around, do it again. And after a while, we'll become a big elliptical galaxy, which is us and Andromeda, I guess.
Well, I'm just going to stop recording, so we just have a...
Okay, so the only thing I really didn't mention, I guess, are